Dear all, welcome back to the Fibonacci number. So today we'll be starting the question of Fibonacci series. The constant is that 0 less than a equals to n less than equals to 30. So we should keep the constant values in mind. Fibonacci number. The Fibonacci number, commonly denoted as f of n from a sequence called the Fibonacci sequence, such that the number is the sum of the preceding ones starting with 0, and that is. So we actually all know the definition of Fibonacci number and Fibonacci series. It is the sum of previous two numbers. If Fibonacci of 3 we know it, then it will be the sum of Fibonacci of 2 plus Fibonacci of 1. So there is also example given that Fibonacci is 2 that is equals to Fibonacci of 1 and Fibonacci of 0. So I have already written the code. I'm just erasing it and I'll make you understand first. Okay. So that was the code that I already wrote. So first try to understand what it tells in the question, that given n, calculate f of n. That means we have to calculate the nth Fibonacci number. We have to calculate the nth Fibonacci number, and I have already given the code. So first, whenever we calculate any things of Fibonacci series using dynamic programming, first we write the base case. And what is the base case? First we write the base case. So now as you can see this code, this coding line is the base case, and then we have wrote our main approach. So we have to find the Fibonacci number, and Fibonacci number already given in the question, that the first Fibonacci series, Fibonacci of 0, that becomes 0, Fibonacci of 1, Fibonacci of 1, that becomes 1, and Fibonacci number is the, and if you want to find the Fibonacci of 2, so this Fibonacci of 2 is the sum of previous two numbers. That means previous two Fibonacci, that is Fibonacci of 1 plus Fibonacci of 0. So whenever we will be writing the Fibonacci type of code, we first have to write the base condition. The base condition. First we have to write the base condition. Base condition. Base condition, that means the returning condition. The returning condition. The returning condition. The returning condition, or we can say the terminating condition, where our loop will terminate. Terminating condition. So first we will write that condition. Here the base condition is only when we get Fibonacci of 0 or Fibonacci of 1, only when. So these are the base values, what will not change, these are fixed. So that is your base condition. So to write those things, we can write like this: if n equals to 0, or now we are writing second condition, n equals to 1, then we will be simply returning the same value 0 or 1. We have to return 0 also and 1 also. How we can return? If we just return n. Return n, so now it will return both the 0 and 1, and this is the base condition, number 1 condition. Second condition is we have to construct a Fibonacci of 2. So there are a lot of approaches. I will utilize here the most optimized. So we can construct it very easily just using a loop, where we will be just changing the number. So now this is Fibonacci of 2. What if you want to get Fibonacci of 3? Suppose we want to get the Fibonacci of 3. So it will be Fibonacci of 2 plus Fibonacci of 1. And if you want to get Fibonacci of 4, so it will be Fibonacci of 3 plus Fibonacci of 2. If you want to get Fibonacci of 5, let's say, change the color, Fibonacci of 5, so it will be Fibonacci of 4 plus Fibonacci of 3. So this is the trend of Fibonacci series. Now notice, observe, when there is 5, there is 4 and there is 3. That means if we consider it with n, then it becomes n minus 1 and it becomes n minus 2. In everywhere this is same things. And notice one thing, first when we are calculating 3, there is Fibonacci of 2 and 1. Now in the second, just notice when we are calculating the next value 4, so the 3, this sum, we can call it that this is the sum, that is the sum. So that the sum came to the value of Fibonacci of 2. That means in Fibonacci of 2 we just assign the sum, and you notice in Fibonacci of 1 we assign this. That is the logic. That means if you assign that type of logic, we will automatically get the code. So for that, first we will declare those. We will declare those in our program, that integer Fibonacci of 0, integer let me remove it. Okay, So now we'll be writing the condition integer fib of 0, fib of 0, integer fib of 0 that is equals to 0, the base condition, and the second that is integer fib of 1 that is 1. Okay, now we will be following the top down approach. I mean yes, this is called bottom up, I don't know, top down bottom up. So we'll be following the bottom up approach. Now we'll be constructing this entire system that I made you understand. So we'll be writing like this. We have gotten 0 1 for, we'll be writing a loop for integer I equals to 2, I less than equals to n, and I plus plus 1, because what we need to return in the question, we need to return the n. So whatever the value will be of n, we need to return that portion. So we'll be writing the code like this. I equals to 2, I less than equals to n, I plus plus. Now we will be just providing integer now the value we will be taking we'll be utilizing here a variable integer sum. Look, this sum, so we'll utilize this variable integer sum that is equals to, now look, this is the previous one, Fibonacci of 2. So we have already defined a Fibonacci of 0, Fibonacci of 1. So we are writing it here for 2. If we just you notice this condition, Fibonacci of 2. So we are writing this condition. So integer sum equals to fib of 1 plus fib of 0. Now we wrote the condition. Now notice what we have done. We have assigned the fib of 2. We have assigned this. First we have assigned, now we have updated the values fib 0, fib 1 and sum. So next condition we have just done that our fib 0 is getting updated. Fib 0 is getting updated. That means this 0th value, this one is getting updated with this Fibonacci of 1. So fib 0 that is equals to fib 1. Okay, as I told. Now in the next step, fib 1 also is getting updated with this sum value. So fib 1 equals to sum, so that value is also updated. Now if you just hike up the code, and if you notice here now fib 1 is containing the most current value, so we'll be returning that fib 1. So simply we will write one more extra line, that return fib 1, and the code is done, and we will get this code will compile with a time complexity of big O of n and space complexity of big O of 1. Why big O of 1? Now notice we have only used one variable here, integer sum. We haven't used any array here, we have only utilized integer sum. So this is the most optimized version. So that is the most optimized version. We solve the code in terms of big O of n time complexity and big O of 1 space complexity. So let's write the code in LeetCode so we understand better. So first we'll be checking the base condition or terminating condition or whatever we tell it, this is. So first we'll be checking if n is equals to 0 or n is equals to 1. Okay, then we'll be returning 0 or 1 according. So we have to return n. This is the base condition. Now we know the value of fib of 0. So simply we will declare that variable integer fib 0 that is equals to 0. Integer fib 1 that is equals to 1. And now in terms of most optimized dynamic programming, we'll utilize only one variable here. So first we need to find starting from 2. We have got for 1, we have to start from 2. For integer I equals to 2, I less than equals to n, I plus plus. And now we will be initializing a variable integer sum that is equals to fib of 0, as I made you understand, fib of 1. And now fib of 0 gets updated, as I saw you, fib of 1, and fib of 1 gets updated by sum, and at the end fib of 1 contains the most updated value. The most updated value, the answer. And so we return just fib1, return fib1. And now let's see if the code works or not. And you can see we have made the 100% of users. So we'll be meeting in the next video with a new algorithm or new LeetCode questions.